Now, speaking of fast, right? Speaking of, how fast is a processor? This is probably the number one question that people will ask about when it comes to processors is, I want a fast processor. And I will tell you that again, in today's world, there's a number of varieties of processors that are out there, a number of different flavors. And I will tell you there's different websites that you can go to that will tell you how a certain processor rates against another processor. And the reason why is because the literal technological aspects that get advertised don't necessarily mean that the processor is going to perform as well as maybe another processor that, the literal technical specs are not as good. And that's where it gets very confusing. But what you need to understand, first and foremost, going into all this, is those literals. Okay, you have to know the actual, terminology and what it means. So when we talk about processor speed, we're talking about the actual internal speed of the central processing unit. And it is measured in something called hertz, okay, which is just Hz. And a hertz is a cycle, right? Okay, so this is where it all, comes back to that first slide that I was showing that I said I kind of jumped the gun, but I wanted to have it out there. It's the cycle, or a hertz is the number of cycles. Now, this speed, or these cycles, is synchronized by something called a clock or a crystal inside the processor. Okay, so that's how many cycles we can do. And we also have another type of speed, which is something called the bus speed, which has to do with the speed of that front side bus or that external data bus, right? So we have the speed of the internal cycles, but then we also have the speed of the bus to be able to transmit data inside and outside of the processor. Now, a couple of other terms that you should be familiar with. We have something called overclocking. That means that you are running the CPU at a higher than recommended speed. Okay, so in the BIOS, which is something that we will learn about in another lesson, in the BIOS, you can adjust certain CPUs. You can adjust their clock settings or that crystal setting, right? That's synchronizing how many hertz, how many cycles you can do per second. You can actually go faster than what is recommended. Now, what do you risk by going faster than recommended? Well, you risk overheating, potentially. Matter of fact, the illustration I have on the screen where I'm showing some cars, you'll notice that one car, is a sports car, and the other one's more of like a family car. So one's probably going to be made to go faster than the other. And with each of the engines that are in those cars, if you were to go faster than the recommended speed, so here we could say we have a speed limit, right? Speed limit 55 miles per hour. That's how fast you should go on the road. You go faster than that, well, you risk getting a ticket. And if you go way faster than that, you may risk overheating or blowing up the engine. Well, processors have that same recommended limit, okay? So maybe it'll be 2 gigahertz, okay, which would be like 2 billion cycles per second. Okay, and if you go faster than that, that's overclocking. We have something called dynamic frequency scaling, which is also known as CPU throttling, which is where you can automatically change the speed or the frequency. And this is a great way to speed up and slow down the processor dynamically as needed to help conserve energy and reduce heat. Okay, help keep from overheating. So one typical place that you might find this would be, on your portable computing devices, like a laptop, okay? Because that is a device that needs power conservation because very often it's being run on a battery. And then, of course, the heat aspect of it is also important because very often these devices you're actually holding in your hands, or they don't even want us to call it a laptop anymore because they don't want you to put it on your lap because it does get hot. But realistically, it is on your lap, and you don't want it to get too hot. Okay. The other issue is even beyond the fact that you're holding it, or might be hot to the touch, is keeping in mind that when you have these smaller portable devices, the ability to ventilate and get cooling to blow through, there's not as much. Okay, when you have a big desktop computer, You know, you can do all kinds of crazy stuff with big fans and water-cooled systems, but with a portable device, you have smaller fans, so you need to make sure that you keep the heat reduced. I also want you to keep in mind that there is, kind of a difference between the actual speed of a processor and the theoretical speed of the processor. And this is where, again, it gets tricky. There's so many factors involved, and why sometimes you got to go out to some of these various ratings websites to see which processors are actually performing better than others, or sometimes it'll be they perform better than others in certain scenarios. Okay, but the actual speed itself is measured by applying the clock multiplier to the front side bus speed. So an example might be a processor that is listed as running at 3200 megahertz or 3.2 gigahertz might be using a 400 megahertz front side bus and an 8 times clock multiplier. Okay, and that's how they get to the 3.2 gigahertz. Right? You have a 400 megahertz front side bus, right? That's the speed that you can actually have data travel in and out, and it has an 8 times clock multiplier. You end up with a 3200 megahertz or 3.2 gigahertz processor, right? It's like the advertised speed that you'll see. The theoretical speed is a product of that front side bus clock speed along with the width of the data bus. Keep in mind, we talked about this a little bit on the motherboards lesson, and we'll talk about it more here in just a moment. We talk about the width of the data bus itself and the number of data transfers per clock cycle. Okay, so things don't always work at the exact literal speeds that are listed.